This recording is going to cover rational exponents and radicals and kind of how they go together. So on the board I got a whole bunch of starting places, I guess. On the left-hand side, let's look at something basic. Square root of 25. Square root of 25 means what two numbers multiplied together give me 25. And that is 5. That should be review. And if I stick a negative out in front, my answer still becomes a 5, but my negative makes that a negative 5. Okay, so the square root of 25 is 5. The negative makes it negative 5. What about the square root of a negative 25? Is that also a negative 5? Remember what square root asks. What two numbers that are exactly the same will multiply together to give me that number? So if I multiplied a negative 5 times a negative 5, I do not get a negative 25. I get a positive 25. And if I multiply a positive 5 times a positive 5, again, I don't get a negative 25. I get a positive 25. This one has no real number solution. Okay, and depending upon your math background, you may recognize the fact that there is something called imaginary solutions, but that's not for this recording. Okay, so there's no real solutions to the square root of a negative 25. It's not possible. All right, let's jump over. What about a cube root? If I had this little superscript up there, it's a root. Okay, it's up here next to my square root, but it's not a square anymore. It's a cube root. That means what number times itself 3 times gives me 27? Well, that would be 3, because 3 times 3 is 9, times 3 is 27. How about the cube root of a negative 27? Is that also not possible like it was with the square root? Well, no, it actually is possible, because a negative 3 times a negative 3 is a positive 9. We'll do it that way. A negative 3 times a negative 3 is a positive 9, and a positive 9 times a negative 3 goes back to a negative 27. So you can take the cube root of a negative. You cannot take the square root of a negative. So what would the negative cube root of a negative 27 be? Well, if the cube root of a negative 27 is negative 3, then the negative in front makes that back to positive. All right, so summarize. You cannot square root a negative. You can cube root a negative. Square root asks what times itself, what two numbers that are exactly the same will multiply together to give me that number. Cube root, what number can you multiply together 3 times to give me that number? So what does a fourth root mean? Well, obviously it's the same thing. What number times itself 4 times? 2 times 2 is 4, times 2 is 8, times 2 is 16. So the answer to this is 2. How about negative? Can I fourth root a negative? I can't square root. I can cube root. Can I fourth root? No. Same reason as a square root. A negative times a negative times a negative times a negative, sorry, I can't write here, is going to be a positive. If you have an even number of negatives, it will turn out positive. There's no way that an even root can give you a negative number. There is no real solution. Okay? No real solution. Did you catch that summary? You cannot take the even root of a negative number, but you can take the odd root of a negative number. All right, let's switch gears. How about a variable? What two letters, what two variables will multiply together to give me x squared? That one's pretty easy. X times x. So the square root of x squared is x. Now, technically I need to throw this in here just because it's mathematically not correct to say it's x. It's technically the absolute value of x. Why? Why would I need to put that absolute value in there? if I say x is a negative 5, and I run through and I take the square root of negative 5 squared. Negative 5 squared is 25. And now I take the square root of 25, I don't get a negative 5. I don't get what I started with. I get a positive 5. I get close to what I started with, but I don't get what I started with. I actually get the absolute value of what I started with. Why? Because when I did this, when I squared it, I actually got rid of that negative sign, and you cannot get it back when you square root it. It's just plain old 5. Okay? I know some of you might be going here and saying, well, if I had x squared equals 25, when you square root it, you get plus and the minus. That is correct. But the square root all by itself will never generate both the plus and the minus. Why do I generate the plus and the minus? Because this thing right here says something, x, anything, squared, needs to be 25. And there are two options. X could be a 5 or x could be a negative 5. Okay? Sorry, that was sidetracked, not really from this section, but I had to throw that in there just to make sure you recognize it technically is the absolute value of x. All right. The square root of x to the 10th. What two numbers will multiply, variables, however you want to say that, expressions, will multiply together that are the same to give me x to the 10th? X to the 5th. Why? Because x to the 5th times x to the 5th, when you multiply like bases, you add the exponents. Remember what this is telling me. X to the 5th says I have 5 x's being multiplied together. Another x to the 5th says I have 5 more. So if I had 5 x's and I have 5 more x's, I now have 10 x's that are being multiplied together. You add the exponents. So let's do another one just really quick. What is the square root of x to the 8th? We are simply dividing the exponent by 2. Okay? What about that one? Let's put it together. What is the square root of 25x to the 4th? Y to the 6th. Take the square root of the number, then take the square root of x to the 4th, then take the square root of x to the 6th. Don't look at that as one big term. Square root of 25, 5. Square root of x to the 4th, x squared. Square root of y to the 6th, y to the 3rd. And if I multiplied 5x squared y cubed times 5x squared y cubed, I would get 25x to the 4th, y to the 6th. So basically you're taking the root of the constant of the number and then dividing the exponent by whatever's the root. So try the next one. What is the 4th root of 16 x to the 8th y to the 12th? 4th root of 16 is 2. 8 divided by 4 is 2. 12 divided by 4 is 3. You are essentially dividing the power by the root to give you the new exponent. Okay? All right. My plan at the end is to throw you a whole bunch of problems, so you'll get a chance to practice. So let's talk about one more topic. Radical compared to an exponent. How do I change an exponent into a radical? You have to have what's called a rational exponent, meaning an exponent that's a fraction. If I have an exponent and a fraction, I convert it into, or I can convert it into a radical. And the way I do it is the top of the fraction represents the power, and the bottom represents the root. So x to the 3/4 is the same thing as the 4th root, because that's my root, of x to the 3rd power. Or it could be the 4th root of x, the whole entire thing raised to the 3rd power. Either one of these ways of writing it is correct. So, what is 36 to the 1/2 power? Well, my power is 1, my root is 2, so really this 36 to the 1/2 is exactly the same thing as the square root of 36. 64 to the 1/3 is the same thing as the cube root of 64. 125 to the 2/3. Bottom number is my root. Top number is my power. I can write it either way. Which way is the easiest to evaluate? If you have no calculator. If I have no calculator, do I know what 125 squared is? Well, no, but I could calculate it. That wouldn't be very fun, but I could calculate it. Could I take the cube root of that gigantic number I get after I multiply 125 times 125? That would be quite a bit harder. However, if I took the cube root of 125, what number times itself 3 times gives me 125? 5. 5 times 5 times 5 is 125. So the cube root of 125 is 5. So now I have 5 squared, and that's 25. So when you are asked to do something by hand, you always, I don't like the word always, but 99% of the time, I can't think of a time you wouldn't, but most of the time, you will take the root first and then the exponent after that. Okay. Fractions with a fractional exponent. Just like you would if you had a square root. This is exactly the same as 64 over 25 square rooted. When I take the square root of a fraction, you take the square root of the top and the bottom. Square root of 64 is 8, square root of 25 is 5, and I get 8 over 5. What about a negative exponent? Remember that? What does 4 to the negative first power mean? Remember, a negative exponent means 1 over that expression. So 4 to the negative first power is 1 over 4 to the first, which is simply 1 over 4. Remember that from some other course? So what about if it's a fraction? Remember talking about that? What if I have 2/3 raised to the negative second power? Really, that's going to be 1 over 2/3 to the second power, which gives me 1 over 4/9. And when I divide by a fraction, I multiply by the reciprocal. So that becomes 1 over 1, really, because that's all that is, times 9 over 4, because I multiply by the reciprocal. And so I get 9/4. Do you see what this negative did to the negative exponent did to my fraction? It really simply flipped it over. And so what I could have done is right away said the negative exponent flips my fraction. So I'm going to flip the fraction and drop the negative. And then I square the 3. I square the 2. And I get the exact same answer as I did by going through all of these steps. A negative exponent flips the fraction. So let's go back to what I had over here. 64 over 25 to the negative 1/2 power. My negative flips that. And so I get 25 over 64 because it flipped the fraction. Now I just deal with the square root like I did before. And my answer is simply just a reciprocal of what I had before. What about this one? 8 raised to the 2/3 power raised to the 3rd power. Remember how to handle a power to a power? X squared cubed means x squared times x squared times x squared. When I multiply like bases, I add the exponents and I get x to the 6th. So really what I did is I multiplied the exponents when I have a power to a power. So a power to a power, I multiply 2/3 times 3. Make sure you remember how to do a fraction. 2/3 times 3 over 1. The 3's cancel. And I get 1 and 1. And I get 2 over 1, which is simply 2. So the negative, now let's put them both together. I have a negative exponent. I'm not going to deal with the negative exponent until after I multiply. So I get 3 halves times a negative 4. If you'd like to multiply first, negative 12 over 2, multiplying top times top, bottom times bottom. Reducing that down, I get negative 6. Or I could have simply done this, got it negative 2 and 1, and multiply 3 times 2 and go straight to the 6. Either way. Now from earlier, the negative exponent means 1 over, so I get that. And 2 to the 6th is 64, because 2 times 2 times 2 times 2 times 2 gives me 64. All right. Let's practice a few. So on these, you just run through them, hit pause as you are ready to come see the answer. Maybe do them all, whatever you want to do. I'm just going to start talking about each one of those. Hit pause, and when you're ready to come on back and see how you do. All right, so here's what I'm going to do. First thing I'll do is I will get rid of the negative sign. And I get rid of the negative sign by flipping my fraction. Okay? So the negative is gone, my fraction flipped over. Now let's take care of the exponent. So I have 125 cube rooted squared over 27 cube rooted squared. Remember, I will 99% of the time do the root first because I can in my head, and I can't very easily square something that large without a calculator. So the cube root of 125 is 5, and 5 squared is 25. The cube root of 27 is 3, because 3 times 3 is 9 times 3 is 27, and 3 squared is 9. Next one. When I divide, I subtract exponents. Just like when you multiply, you add. When you divide, you subtract. So what this really is 3/4 minus 1/2 as an exponent. You need to clarify that. When you divide like bases, you subtract the exponents. All right, common denominator. So my common denominator will be a 4. So I have 3/4 minus 2/4, which is x to the 1/4. If we wanted to write that in radical form, that would be the 4th root of x. Good question might be, write this in radical form. Write the solution to that in radical form. Okay? All right, next. Getting harder. When you have a power to a power, you multiply. And when I have multiple terms raised to a power, I multiply each of their exponents by that power. So 2/3 times 2/3 is 4/9. 2/3 times 1/4. I'm going to reduce first. I get a 2 and a 1, and I get 1/6. 2/3 times 3/5. Hopefully you can see that is 2/5 because the 3's cancel. And we're done. Next one. Like bases, we subtract the exponents. We subtract the like exponents. So 3/4 minus 2/3. Common denominator is 12. So this becomes 9. This becomes 8. And so I get a to the 1/12. B, 2/3 minus 1/2. Common denominator is a 6. Multiply the 2 by a 2 and I get 4. Multiply the 1 by a 3 and I get 3. And I end up with 1/6. You're done. Last one. Last one will make you think a little bit. Last one's a good one. All right. I'm going to, we could do this a couple ways. I'm not sure which way is the fastest. I'm just going to use the same procedure as we used before. I'll take care of the negative first. At this point in time, we could subtract first, or we could multiply both of those exponents to the 1/2. I think I'm going to subtract first. So I have 3/4 minus 2/3. And if I remember right, we just did this. Common denominator is 12. And I get 9 minus 8, so I get 1/12. So I get b to the 1/12 raised to the 1/2. When I have a power to a power, I multiply, and I get b to the 1/24th power. Now, there's a lot of different ways to get to that same answer. That's the way I chose. I could have taken 2/3 minus 3/4 right at the very beginning, then multiplied it by negative 1/2. There's lots of ways I could have done it. Let's do it that way. I just want to show you that way real quick. So I have 2/3 minus 3/4 right away. And if we think about what we just got, that would have been 8/12 minus 9/12, which equals a negative 1/2. Nope, 12. So what I end up with is b to the negative 1/12 raised to the negative 1/2 power. When I multiply, I get b to the 1/24th. Maybe that was a little faster. Maybe one step faster. Either way, they both work. All right, if that made sense, you understand radicals to rationals, or to rational to radical exponents and vice versa.